In this video, I'll show you how to find the general integral involving forms of the power rule. This is also known as finding the antiderivative. So we're going to be looking at functions that we can rewrite in the form of x to the power of n. And we're doing the power rule for derivatives in reverse. So we'll be raising it to a power higher and then dividing by that power. And we'll always add a plus c at the end for some constant that would end up being 0 if we were to take the derivative working backwards. But again, we're finding the antiderivative. So basically, we're going to use the phrase bump up and divide. So we're taking whatever goes in this blank to that power and bumping it up a power, and we're going to divide by that power. Let's take a look at some examples. So our first two are very easy. We see that we have x to the third, so we can say, all right, a power higher would have come from x to the fourth and divide by that power, plus c. This can also be rewritten as 1/4 x to the fourth plus c. Done. And if you check that derivative, you'll have 4 times 1/4, which is 1, x to the power less, which is a third. Now, if you have 4x to the third written down, it really doesn't change anything. You can pull the 4 in front of the integral or just deal with it. I say we deal with it. We rewrite it as 4x to the power higher, divide by that power, plus c. Those 4's cancel. You're left with x to the fourth plus c. Can this get any more difficult? Yes. There's 8 basic examples I would like to look at. The first one's pretty obvious. It's just if there's addition or subtraction, you deal with it. So we take the x to the fourth, raise it to the power higher, it's to the fifth, minus we have 3x squared, so the power higher is the third, divide by 3 plus c, and we simplify. So you can apply the same rules when there's addition or subtraction, but you cannot apply them for multiplication or division. So be very aware of that. And we have that. Number 2 is where we start to deal with negative exponents, so you're going to want to remember your exponent rules. So remember that 3 over x to the fourth is the same thing as saying 3 times x to the negative fourth. Now we have the template we want, x to a power. So we'll do the same thing, 3x and a power higher of negative 4, remember, is negative 3. And we'll divide by that negative 3 plus c. That leaves us with negative x to the negative third plus c. And maybe they'll want to rewrite it as negative 1 over x to the third plus that constant. Next up, we'll see the idea of distributing. So with multiplication, we can't apply the rules. So we do have to distribute first, and if you do, you'll have x to the third plus 2x. So we'll do that to a power higher. So we'll have x to the fourth divided by 4 plus 2x, a power higher would be squared, divide by 2 plus c. So we're left with 1/4 x to the fourth plus x squared plus c. And not only can you distribute with multiplication, but remember, you could distribute with division when there's a monomial denominator, so just one term. So we'll do the same idea here. So we're going to have 5x divided by x plus x squared over x. And that's going to simplify simply to 5 plus x. Now for 5, we don't see an x there. We should know that 5 is the slope of 5x, so we can do that. Or really, you can consider this x to the 0 when you're doing a power higher. And then the x, a power higher, is 2 divided by 2 plus c. You may recognize this is just a quadratic, but I'll just keep it pretty much in this form anyhow. And we have our answer. And then we may have to deal with square roots. So we'll have to remember how to rewrite square roots, which is pretty straightforward for everyone. So just recall that the square root of x can be rewritten as x to the 1/2 power. So in this case, we'll have x to a power higher of 1/2 is just 3/2, and then we're going to divide by 3/2. But I'm going to want you guys to remember that dividing by that fraction is the same as multiplying by its reciprocal, and we'll end up in the habit of just multiplying by the reciprocal after we raise it to a power higher, and we're left with 2/3 x to the 3/2 plus c. So when we see other roots, we're going to do the same thing, and if we have to deal with negative exponents and square roots, we will. So this one can be rewritten as x to the negative 1/2 power plus x to the 1/3 power. So now here, when we raise it to a power higher, we're going to have x to the 1/2 So instead of dividing by a half, we'll multiply by 2, plus x to the power higher here is x to the 4/3, and instead of dividing by 4/3, we'll just multiply by 3/4 plus c, and we're done. And again, you can always rewrite this using radical forms such as square root and cube roots. Next up is the idea of expanding. We can't just apply the power rule here because, again, we still need the form of x to a power, and we have parentheses holding us back. So we'll need to expand this, and we should know that x squared plus 1 squared is simply x to the 4th plus 2x squared plus 1. Now it's easy. So a power higher is going to be x to the 5th over 5 plus 2x power higher is 3rd over 3, plus again that 1 is the slope of 1x, so we will write 1x for now, and then have plus c. Simplifying this gives us 1/5 x to the 5th plus 2/3 x to the 3rd plus x plus c. And there we go. Number 8. Number 8 is the one to watch out for. When you're left with the integral of 1 over x, you may be tempted to rewrite that as x to the -1, which would be true. But when you raise that to a power higher, when you add 1, we're going to have x to the 0 dividing by 1. So you should know you can't use the power rule here. So we're going to x that 1 out. We're going to have to remember that 1 over a linear function is going to make us think of, there it is, ln, okay? So 1 over x is the derivative of ln of x. But watch out. So with 1 over x, the domain is x not equal to 0. For ln of x, it's x greater than 0. So we will include absolute value bars here, and it becomes ln of x plus c. It is not the power rule. More to come.